our recording of information about how to run your data center like you drive your car. So hello, everyone. My name is Mike Crabtree. I'm an IT solutions consultant based out of Toronto, Canada. And I have with me one of my colleagues, Sandy. Could you just quickly introduce yourself?
Sure, Mike. Hi, I'm Sandy Snyder, and I am an ITOM solution consultant as well. I'm out of the suburbs of Philadelphia.
Okay. And Sandy and I come from slightly different angles on this. So my focus is around the service management side. And Sandy, your focus is really around that event monitoring side from all the different aspects that events come in from, yeah?
Yes.
Yeah, okay.
Yep.
So
all different kinds.
Right, yeah. And there are lots of different kinds of events and performance data that we need to capture. Yeah? So today we want to sort of discuss 5 simple ways to think about how you run your data center and how you compare that to running it like your car, which seems a very strange thing to do. But I think once we've gone through this, you'll understand our very simple perspective of running a data center is actually fairly straightforward if you break it down to some very simple things. So there are 5 things that we need to look at. One is to define the service that you provide in the same way that a car provides a service to us, your data center does. There are ways that we actually get to see how well that data center or those services are actually running. So we'll talk about that in terms of things like dashboards for business users versus the detailed metrics that you might pick up. One of the things that a car does very well, particularly with modern technology, is automating everything. And that applies just as much to running a service inside a data center or in cloud. There's just too much going on. You have to automate things. The 4th item is to use the controls that you do have to adjust the performance. So in a car, you've got sport mode and eco mode. Well, you've got similar things in your service where you can scale up and scale down, those kind of things. And then the final item is about maintaining your service. How do you maintain your car? Well, you have to do similar things to maintain the services that you actually run. They don't keep running all the time. They need looking after. So let's sort of dive into this. And let's start off with the first one. So you must find this strange, Sandy, talking about how a data center looks like a car. But do you see the analogies? Do you start to see things there?
Yeah, I definitely do. I mean, I think that you're still trying to define your service. So, like an automobile might be is basically its service is to get you safely from point A to point B, and in as comfortable a manner as possible, and probably as quickly as possible. Where I see the same thing from a perspective of your data center, whether you need to be able to run a successful business and define that service, whether it's what you're providing and delivering as a profitable service or a product to your end users. Being able to make sure that the environment is up and running and they're able to actually run their business service. For example, like an online shopping application, being able to have it up running and be able to have people come in and successfully and expediently just search for something and then be able to buy it and then fulfill that through the IT process so that they get their merchandise.
Right, and I guess in defining that service, you're going to be looking at, well, how am I going to support it? How many users do I have to have service through this?
Yes.
What kind of performance am I expecting? It's the same when you go and look at a car for the first time. It's like, well, how many passengers do you need? What kind of speed do you need to do? Do you need to carry anything else, on the roof rack and things like that? So you define that service very clearly up front as to what it is you're trying to achieve and do with that. So,
exactly.
Okay, so once you've actually got your car, you've defined your service and where you're going to go, and the same with your business service, and you've got that definition clearly laid out. And to me, everything in IT is about providing a service to a business user or a group of business users. But what kind of information do we really need to provide to those business users? So again, from your world of event monitoring and management, there is a ton of information that you gather about how a system's working, but what do you really provide either internally or externally to business users?
Yeah, it's a very good point, Mike. And also what you said before, too. I mean, I think how you define and determine your car with all those parameters coming into it. In a lot of ways, you have to define, it's more like defining your service level management as well to those particular business services from an IT perspective. Some may have a whole lot stricter service level management than others. And as far as how do you provide that high level dashboard and that capability from an IT perspective, I really do think that there, like as you mentioned, there's so many things coming in, whether it's coming in from your network, coming in from the servers themselves, the applications that are running on it, the end user performance, cloud monitoring. There's so many components that can be coming into it. And I think the key too, is be able to bring all that information in and then be able to digest it and then be able to provide like similar gauges that you do to your car to different users. So from a knock perspective, you want a knock dashboard so you can actually see where you're seeing your problems. You have an idea of what the individual network performance is, for example, or are the incidents all of a sudden coming up? Or are we starting to get bad performance for users? So that's what the NOC wants to see. What are the actual problems so we can go fix those problems? But at a higher level, management actually wants to see more business level type information. They want to know that the infrastructure is running, but they don't need to know the details of what's going on, just if it's performing to their SLA. And then also being able to find out information from a business perspective too. So are users abandoning their cart on your online shopping network? Are you seeing the number of traffic that you expect to be coming through your site? Those type of business things can also be portrayed as well, as along with the IT infrastructure underneath it.
Right. So you're really looking at the value that you're providing to a business in terms of all those things, but not just in terms of IT CPU performance, but the value of maybe the transactions going through a system. Yeah. And I guess in terms of a car, we talk about a dashboard all the time. We just don't use that terminology maybe all the time, but it tells you when the fuel level is low, the tire pressure is low, but they're very simple and straightforward things that a typical car user can deal with. But I guess when you get to that thing where the check engine light comes on, as a typical user of that service, that car, that automobile, you don't do anything with it except to take it to the experts and let them actually do that diagnostics with an OBD scanner, for instance, to actually read the details of, the richness of the fuel mixture that's running through the system that's maybe making it misfire or something. So different people need different views on what data is coming in.
Definitely. Yeah. I mean, the actual NOC people and the staff, and the IT staff are the ones that are going to get the scanner for you, but you want to be able to provide your value and be able to show how things are running at a higher level IT management perspective as well as into the business.
Okay, so we've now defined what a service might look like. And how that relates to having an automobile. We've looked at that high-level view, as in using your dashboards and your warning lights that come in for a business user, but being able to drill down and get that detail. There's a ton of things that are going on inside any service. And these days with all the virtual machines and cloud and just the vast amounts of data that we're dealing with, typical operations management teams can't deal with all of that. So how do you suggest that people actually deal with the vast amounts of data?
So I think more and more people are looking at this. We need to be able to have automation take over and actually do some of the things that a normal, in the past, a person would do, especially in the IT perspective. So you might have your level 1 operators that are looking at an event, and then they're actually opening up a book and going through the individual processes to do that. We need to be able to automate those processes. So from an automation perspective, we can see these events come in and actually act upon those events and try and auto remediate those events so they are fixed without any human intervention. On the same lines, I think we need to be able to use some automation correlation capabilities too, to be able to determine how those events make sense and how they can be interrelated to one another. So again, being able to reduce the number of events, be able to determine when you're getting an event storm and cut out the noise. So get everything down through automation to have your staff actually looking and working on the most critical events, the causal events, and then also the ones that may be too complex to be able to be automated.
So this is really using computers, in effect, that technology to be able to help us automatically manage everything that's going on inside that service, in the same way that in your car, you would probably have an engine management system. And that's going to adjust to your driving style, it adjusts to the road conditions. I know within AI Ops, we talk about things like seasonality. So when you've got a burst, say at the month end or a year end or something, and there's a burst of transactions going through, we deal with that same kind of thing in a car when it deals with traction control. And that reacts much quicker than any humans can. I know that within Porsche, they say that their automatic gearboxes are actually far superior to anything they do with a manual gearbox because of the technology behind it and the computing. It can just react so much quicker.
Yeah. And I think, yeah, exactly. One of the things I like to kind of relate in AI Ops to what you're saying is exactly the seasonality and creating baselines. So years ago, and a lot of people still do, when you look at what you want to say is a high CPU or something, or a high memory utilization or a network utilization, you really want to be able to not just make it a set number and a static type of threshold. You want to be able to use analytics and be able to actually determine what is a dynamic, do dynamic thresholding. And like you said, being able to use that seasonality to say, if I'm an online shopping application, well, I'm going to have a whole lot higher utilization perhaps on a sale day or over the holidays, that type of thing. So we can use analytics to be able to do that and to do some of that machine learning like your engine system's doing, and to be able to tweak and tune things for you and without human intervention.
And I guess that if you can then start to see that using that analytics, then you can start to do predictive analytics as well, and actually see where things are going to go to in the future, which is really important. Yeah, it's interesting. I talk a lot to customers about, as you mentioned, that a lot of people put an event out if the CPU is high. But that's not the only thing. It's like, well, if CPU is high and network is high, but the transactions are still going through at a high rate, then that's actually still good. You're actually just making good use of the machine. It's when CPU is high and there's zero transactions going through, then there's a problem somewhere, yeah, because it's not going through. But now, I guess once you really start to get into analyzing and doing that seasonality and this predictive stuff, you can then start to use that information to then apply controls around that service. So within a car, you'll start to do other things like tuning the exhaust. You'll maybe use sport mode and eco mode, and a car will actually reshape its service. It will actually change the way the engine management system works on if you've got a very heavy accelerator foot and it can sense that you're trying to get somewhere. I assume we could do that with our AI Ops capability now that we start to understand that thing.
Yes.
Yeah.
Definitely. I mean, we can start to use the AI Ops capability to start to do some forecasting on capacity. We can start to do it to actually start looking at anomalous behavior and give us a clue and an idea as to a predictive kind of idea as when something's going to go wrong or when something needs attention. And then being able to use the capabilities that we have not only in AI Ops, but kind of across the portfolio gives you a chance to be able to do kind of the same thing as you're mentioning, be able to start to look and predict and forecast when you need to be able to reshape your business service. So actually scale up and scale down the infrastructure in a virtualized cloud environment. That's a very easy thing to do. So you can actually start to see how when you're starting to run into some performance issues, you can start to see again that pattern that's happening, and then be able to scale up and scale down the infrastructure, put on more web services.
Okay, I guess that's ideal if you're in a virtualized environment, as you say, or a cloud environment. It's very easy to actually bring those extra resources online and just close them down when you don't need them. But you need the analytics, I guess, to be able to really do that properly.
Yeah, you need to be able to understand what's going on in your system, and that you do need the analytics for sure. And we've actually seen, we've used some of our network monitoring tools to actually do that in real life with the COVID-19 work from home. We have a number of customers that use our tools that were able to use the baselining and the thresholding and be able to determine what was going on, and looking at the traffic analysis as they moved everybody out of their nice office spaces on fast LANs to be able to scale up again.
So then, if I guess they must have had a baseline before COVID-19. They could see things start to change, and then once we're in that sort of COVID-19 state, did they then sort of reset the baseline for?
Yeah, and they were able to determine which circuits needed to be increased as far as bandwidth and throughput through, and they actually were able to use the business value dashboard technology that we talked about earlier, and to be able to create dashboards for not only the NOC but also for the business to see, to be able to determine if there were issues going on between people working from home and being able to communicate with one another, and what
right. So
that's
a real HR type decision about dealing with people working from home, as to how well they're able to actually be effective, and
right.
it based on their network connectivity, etc., into the central data system. So that really comes back to even that business level dashboard that we talked about earlier on.
Yes.
Yeah. Okay. So, all right. So we've talked about defining the service. We've talked about that high level view through a dashboard system, but also being able to drill down if you're internal, and you really need to get into the engineering side of things. We talked about automation, and using that analytics and even the predictive analytics to see where you're going in the future, and then using those controls to adjust and reshape your service through scaling up and scaling down. But the last one, I think I feel is quite important as well. So with a car, one of the things that you need to do to keep that car running at its peak performance is to do regular maintenance. You take it in for your oil and filter changes, you do the new tires, you do 50K and 10K mile maintenance and those kind of things. But you've also got lots of things that are telling you what's going on with the system in between that. So you have tire pressure monitoring systems, engine oil temperature, coolant temperature, your check engine light, as I mentioned earlier on. But you also use your ears and say, well, something sounds different than it usually does. How would we relate that to monitoring and preventive maintenance in a sort of data center system?
Yes, so I think that you're very right in all those things, and I think that one of the things it has to start off with is a good design and planning for how you want your data center to be laid out. So you have design built in for high availability, disaster recovery. So the architecture needs to be laid out properly to handle failures, outages, be able to keep those services running. And then once you have that architecture laid out, then you need to have robust monitoring systems that have that similar capability within them. So you can, if your network monitoring solution fails, you have a way to fail over to another monitoring systems. You also need to be able to understand, I think, going back to that business service level management thing too, I think you need to have different categories of how things need to be monitored and in what levels they fit into. Some infrastructure may be monitored very lightly because it's not of a critical mass. But once you have those business services defined, you need to be sure that you have a robust monitoring policy set up on the more critical business services. So you're getting data faster, you're monitoring it more frequently, and then you have policies in place to alert when there's a problem, and then to be able to have capabilities of scaling up and scaling down when necessary.
Right. So I talk to customers a lot about applying their monitoring and their management technologies, but even back as far as their test and QA systems, not just waiting till they get into production, which I hear a lot of customers doing. I'm a big proponent of starting as far back in that cycle as you possibly can. But I've also, you mentioned about things like clustering and failover mechanism. Absolutely. when you have a critical system, you have to understand how that clustering or that failover mechanism works and test it on a regular basis. But what I've also seen people do is they trust that the clustering and failover mechanism is all they need, and they don't do the monitoring with it.
Correct.
So I've seen customers that have had a cluster, and this is going back to things like Veritas cluster and Sun cluster, and machine A fails, and it fails over perfectly onto the second system, onto machine B, to the point where it failed over so perfectly that the customers didn't notice that there was a break in service, only to find that 2 or 3 months later, that second machine failed, and it tried to fail back to the first machine, but they hadn't fixed the first machine because they weren't monitoring even the basics of a log file. So when you have these technologies like HA systems, you have to make sure the monitoring is absolutely put around those technologies.
Absolutely. It's kind of like that. You can't just assume that HA is going to take care of everything. They're just not your belt. You need like a belt and suspenders. So you need to make sure that you're monitoring both of those environments, and you know what's going on, and things aren't too automated, like you said, to fail over and then not be aware of the problem on the primary system as well.
Right. The other thing I know that I've come particularly from a hardware background, so I know that there are early warning systems that come out from a lot of hardware components like disk failures and overheating CPUs. These are telltale signs that something is going to fail. And I guess the monitoring tools are ideal to pick up that kind of stuff and actually warn you before they actually fail.
They are. They definitely are. I mean, we do a lot of component monitoring in our network operations management suite as well. All those indications are coming through. They're coming through as alerts, and they're prioritized, so you're aware of what's going on with them. And similarly, we have integrations to be able to pull in, and you want to be able to pull in all the hardware monitoring capabilities that are coming from the vendors onto your servers, and be able to pull that information in as well, and be able to proactively, when you start to see something overheating, to be able to call out the engineer to be able to fix that, so you're not ignoring it till the actual machine crashes itself.
Right, and I guess, I mean, we're talking very hardware centric here, but to me it applies exactly the same if you have a cloud service. Yes. In that there are things underlying that supposedly AWS and Azure, they take care of a lot of that detail, but understanding what's happening with your service, maybe not down to that absolute detail of a CPU, but just being aware of it and monitoring it is still critical, even in those services.
Yeah, it absolutely is. And I think it's critical to be able to continue to understand as they're moving things around to how that affects your business service. And the other proactive monitoring type things that you need to do to keep things running, you do have to monitor how your application is actually performing. And again, not only just looking from a hardware infrastructure perspective at looking at early warning signs and dynamic thresholds, you need to do that in that environment as well. Because all of a sudden your response time could be slowly creeping up over time, and you're kind of like the frog in the boiling water. You don't notice it.
Oh, right. Yes, true. Yeah. That's a good analogy. I like that one. Okay. Okay. So we've kind of gone through the 5. Let's just see if we can recap on those 5 that we've picked up on today. And Sandy, just jump in if there's any comments you want to make on this. So
sure.
we talked about that, defining the services that you provide. And again, a car provides a service the same way as your IT group provides a service. And with a car, most users actually only open a hood to put the water in for the windscreen wiper. They don't actually understand anything else that's happening inside there. But obviously, the engineers, when you actually do go to a place, that's the difference between having a dashboard that gives you very basic information and the onboard diagnostics. So first, you're defining that service.
Right. So in the case of the business, we're looking at giving them that higher level. All you really care about, not the details of how it's really working, is filling in the windshield washer fluid.
Right.
We want to give you that business value dashboard at a higher level. So you need to know how things are running, but you don't necessarily need to know the details. You just need to be able to call the right person when there's a problem on the screen.
So we got the first one is defining services. Second is that dashboard kind of view for the business users. Third one we've got is automate everything. Again, just the amount of data that comes through, you have to automate these days. There's no way you can really run typical systems without automating.
I'm sorry, one thing on that one that I kind of forgot to mention when we were talking about it was I think it's important too, not only to be able to automate when you have an event or an incident come in, it's also important to be able to use automation to do that scale up and scale down with provisioning and be able to use it not just to rectify an event, but also to be used in that scale up and scale down process.
That's that predictive capability, yeah?
Yes.
Yeah, so that's where that brings us directly onto the fourth item. So that's that, using those controls to adjust the performance of that service that you've got. You've got the ability to do, as you say, things like scale up and scale down. We need to make sure that we use those, but based on good information that we're being provided. And then that fifth item, maintain your service. Take the time to maintain your vehicle the same way as you need to take the time to maintain your data center. And things wear out. It's an interesting thing that even just Tesla in the last week or so has confirmed that their CPU in a Tesla vehicle is considered a device that wears out, just like a tire or anything like that. So you need to be monitoring these things and seeing how well they're wearing out the same way as the Tesla battery wears out over time. So amazing, fantastic new technologies that we have, but they still need that monitoring and performance monitoring, event monitoring in place across everything you're doing. So, okay, this has been really cool. Actually, looking at how you treat your data center like you would treat your car. So I think we've learned some really good things today. Thank you, Sandy.
Thank you,
I think this all puts it into a really great perspective. Yeah. Any final comments you'd like to put in?
I think I'm good.
You're good. Okay, that's great. All right, thank you, Sandy, and thank you to everyone else for listening. Hopefully, we'll get to speak to you about our next view of how you treat your data center like something else, maybe, maybe like treating it like you would treat NASA or your aircraft or something like that. Okay, thank you, everyone.